The third problem. An inductive coil is connected in series with a resistance of 50 ohm across 230 volt, 50 Hz AC supply. The voltage across the coil is 180 volt and across the resistance is 130 volt. Calculate resistance and inductance of the coil. The power dissipated in the coil, say P coil, and also draw the vector diagram. Alright, so let's solve this. What I have done is I have just collected the problem data and I have constructed the circuit from the given problem data. Alright, so we have resistance value 50 ohm and we also have drop across the resistance, that is 130 ohm. So having known the resistance and the drop across the resistance, we can find the current flow, that is I is equal to VR divided by R. VR is 130 and resistance value is 50, so that will give you a current value of 2.6 amperes. Alright, and then okay, so we have magnitude of current as 2.6 amperes. Once you have this current, you can find out the impedance of the coil because current is known and you also know the voltage across the impedance. So say mod ZC. Mod ZC is equal to VC divided by I. So VC is 180 divided by I is 2.6. So that will give you the impedance of the coil as 69.23 ohm. Okay. Also, we can write, the impedance of the coil in complex notation, such as Zc is equal to R plus JXL, or Zc square is equal to R square plus XL square. Okay. So you take this as equation 1. In future, we will be using this particular equation. Okay. Next, you can also find the overall impedance of the coil. So overall impedance of the coil, let us take it as ZT. So what do we have as the overall impedance? We have pure resistance R in series with the resistance of the coil, and we also have the inductance of the coil, J into XL. Okay. Or with the problem data, you can find mod Z total. So mod Z total is equal to voltage by current, 230 divided by 2.6. So you will get Z total as 88.40. Alright, and now let us try to find out the value of R and L from the Z total expression. Okay. So Z total can be written as modulus of R plus R the whole square plus XL the whole square. Okay, it is simply the real part square plus imaginary part square. Okay, so we have Z total is equal to under root, okay, or rather you can square the LHS as well. So we have Z total square is equal to, you can expand, it is capital R square plus small r square plus 2 times capital R into R plus XL square, or you can substitute the values. Z total is 88.4 square is equal to R square, that is 50 square plus 2 into R, that is 50 into small r, which is unknown, plus, this is what I was pointing out earlier, you see this, R square plus XL square. So R square plus XL square, basically it is ZC square. and ZC square is nothing but 69.23 the whole square. So you can directly write 69.23 the whole square. Okay. And now what you can do is you can rearrange the terms to get the value of R. So R is equal to 88.4 whole square minus 50 square minus 69.23 square divided by 2 into 50. So you will get the value of R as 5.326 ohms. Once you have this R value, you can find out the XL value, and from XL value you can determine the inductance of the coil. So XL is equal to under root ZC square minus R square, or XL is equal to under root ZC, which is 69.23 minus R square 5.326, or you will get XL value as 69.025 ohms, or you can find out L is equal to XL divided by 2 pi f, that is 69.025 divided by 2 into pi into frequency. So you will get L is equal to 0.22 Henry. So you have found the R value and also you have found the L value. Okay. Now you need to determine the power factor of the circuit. Okay, so to determine the power factor of the circuit, let us construct the impedance triangle. So while constructing the impedance triangle, resistances you take it along x-axis and reactances you take it along y-axis. So what do we have here? We have pure resistance R and choke resistance small r, and then comes the reactance of the coil. So the closing side of this triangle basically gives Z coil, and this closing side of the outer triangle will give Z total. Okay, so this angle is called as power factor angle of the coil, and this angle is called as the overall power factor angle. So you were supposed to find power factor of the overall circuit, so you can find power factor of the overall circuit as cos phi, which is basically PF, and cos phi is equal to adjacent side. So adjacent side is basically this distance, which is R plus R divided by Z total. So how much do you get? R was 5.32 plus 50 divided by Z total. Z total is 88.46. So power factor of this circuit is 0.625 lag. Once you are done with the power factor, you can draw the vector diagram. Okay, so vector diagram is also pretty easy. Once you understand the impedance triangle, it is very easy to draw the vector diagram. Okay, so while drawing the vector diagram, what you can do is you can take current as the reference vector, and with respect to current you can draw the voltage vectors. So firstly we have voltage drop across the pure resistive elements, we can take it as VR, followed by, which is I into R, followed by the drop across the small r, which we shall take it as V suffix small r, which is I into small r, and then we have drop across the inductive element, which we will take it as VL, where VL is equal to I into XL, and then we have the resultant, which we can take it as VC. Okay, so VC is nothing but voltage drop across R and voltage drop across L. So basically the vector addition, and this is your phi coil. Alright, and the closing side of outer triangle gives supply voltage V. So when you calculate V, you are supposed to get the value of V as 230 volt, and this is the phase angle phi. Alright, so this is the vector angle.